going to Google search, and then one of the top listed author was Davide, and then I was looking from where he is, and then I saw, hey, actually from Switzerland would be a nice opportunity to get more insights from him direct. I'm looking forward to his speech, and we have for sure time to discuss some issues. Okay, we are starting. I just shortly present. I think you will present yourself also a little bit, Davide, correct? He is a senior researcher, as I said, at the University of Applied Science and Arts in the west part of Switzerland, so-called HES-SO. There he is in the Institute of Information Systems, that would be comparable with our Wirtschaftsinformatik on our German side, and his email, you have it. He will also share his presentation with us, so we will upload it to our Google Drive, so you have access. Here's just some literature, as I said, I found on Google Scholar. There are much more, to be honest. You are quite active, Davide. But just that you have it here, some which is more the related one. You can maybe pick then the one you say that you have to read of it. Because I didn't go through all of them, to be honest, but some I read and quite interesting. And that's I will hand over the micro to you, and also the presentation. I just will put it down. So thanks a lot that you're here, by the way, and we are looking very much forward to hear your insights about blockchain and multi-agent systems.
So first of all, thank you everybody for being here, and thank you, Michael, for the invitation first and the introduction later. So here the speak today will be about how to merge intelligent systems and blockchain, with a specific focus on the multi-agent system, which is one view of intelligent autonomous systems. So as Michael introduced, I joined Michael Schumacher group, which is called ISLab here in HES-SO, University of Applied Sciences in Western Switzerland, in 2016. And ever since, we have our contribution span over safety critical application, ambient assisted living, e-health, e-tourism, and overall application of distributed AI. As a main topic, my expertise spans from real-time multi-agent systems, blockchain and multi-agent system, digital telerehabilitation, a new branch recently opened about explainability in multi-agent systems, and with my startup I'm co-founder of, we investigated monitoring in real time of the tire wearing for trucks. So today, of course, it will be only about, luckily, only about one of these topics, which is blockchain and multi-agent systems. And this topic is particularly important for us, that we really care about, because although, let's say in our daily application, we have dealt with very broad plethora of systems that span from very, let's say, embedded devices, wearable sensors, up to very abstract frameworks that can perform distributed thinking, and so at several degrees. So we can see that doesn't matter which abstraction these systems are, all of them are somehow approaching the network. So all of them are getting distributed. And when you go on the network, when you add the social layer to the system, of course, there is one common challenge to all these type of systems, which is, of course, accountability. So there is a need for trusted entities, trusted data, trusted interaction, even when the scenarios are assumed to be trustless. And of course, the common solution that nowadays is very trendy is like blockchain. And so that's what we did. And I can confirm that it's been a topic extremely interesting, and a mix that hopefully will still keep going. So as mentioned, these are the two main players. Many of them, I'm sure, are already confident with the blockchain, which I will just slowly introduce later on. And I will try to dive in a little bit more into what is multi-agent systems. So a multi-agent system is sits at the cross between artificial intelligence, distributed computing, game theory, and social science. And the core, the pillar element is the concept of agent, which is a virtual entity that, according to several definitions that have been given along the years, I am more affectionate than the Russell and Norvig one, which is the most simple and the most that conveys the message the most. We can see it as anything, as a virtual entity that can perceive and actuate the environment after its own process of thinking. Okay, so we have the concept of environment, the concept of intelligence, sensor, and actuator, and given the multi-agent aspect, also the concept of community. But starting from the single agent to understand it a little bit more, we have the knowledge representation, we have a set of behaviors that the agent can perform, and we have, of course, interaction and negotiation protocols that we will dive a little bit more afterwards. The main characteristic of an agent, if we can hazard an easy parallelism, is with the object-oriented paradigm. So while we have an object and we have its method that at any time can be invoked from whatever call, whatever function, the agents cannot be invoked. Let's say they have their own autonomy, and if you want to ask for a functionality, you need to go through its acceptance process. So we have an independent decision-making process. Of course, these while agents are, except for triggers, objects, except for triggers, they are reactive. With agents, we have also the concept of proactivity. So the process of developing either new goal or a merging goal that can be single, so selfish goal or community goal, so that they are collaborating in a common goal for the community that can be also decomposed in small singular goals. And then another great property of this approach that we have, that is named a multi-agent system, is like the mobility of the agent. Let's imagine just that the agent can be paraphrased as a code that has some capabilities, and rather than, for example, moving data that needs to be elaborated and dealing with all the data protection, privacy, and so on, we are able to move only the code that is, let's say, concerning the agent. He will be elaborating what he has to do with the data, generating his knowledge, and bringing only that away with him. So visiting all the peers that are hopefully, assumably trusted, and that belongs to his network. And we can have different specialization that can, let's say, focus on different layers of this data learning. Indeed, there is a huge branch of literature that deals with machine learning and multi-agent system, where we can find both online and offline learning, and where we can have the behavior that I mentioned before of the single agent adapting to the environmental change or adapting to its goal or its priorities in a very dynamic way. Of course, the social ability is extremely important and relevant, is one of the key points of this approach. And we have these entities that are able to communicate according to some given protocols and shared approaches, and they can give and require data, and they can also negotiate, so contracting also the performance, not only which information to give. The agents have a strong rationality. They also get expressed as goal-oriented. So their objective function always to reach something, not to avoiding something else. So it's really well explained. And of course, as the object-oriented paradigm, they are also reactive. So they can be pinged according to events or environmental changes. To give a more systematic representation, we can see here the schema, where we have environment once again that get perceived, and then we have two new elements, which is the word model, so the word representation, and a planner. Here there are several theories as well that can span from open word assumption, closed word assumption, but let's assume for simplicity today that every agent has a limited view, a limited knowledge of the word that can be as approximated as we need, okay? And sometimes this knowledge can be amended, so it can be extended or can be revised. And this, of course, impact the behavior that depends on the planner, which can be seen as the actual, let's say, brain, the actual motion that triggers future actions. The multi-agent system have several positive sides. Just to mention a couple of them, not to be too long on this. the logic, the using logic representation is extremely easy. Let's say the reasoning upon explicit symbolic representation is one of the pillars that have been studied and developed in recent years. Indeed, like just touching slightly another branch of my research, which is explainability. Let's say bridging machine learning, which is sub-symbolic, so numerical representation of the knowledge, with symbolic and force manipulatable knowledge is extremely important, extremely relevant. Indeed, is peaking in recent interest of the research environment. Of course, then there is a robustness because it's distributed and so on. So several other strengths that we can allow for this technology. As well, we have some let's say some drawbacks, which, for example, to mention one above all, being a distributed system that mimic, let's say, the social behaviors of the human being, security and trust are two of the most, let's say, two of the most concerns, biggest concerns. And of course, being a system, a design that involves so many components and nested components, the response time and complexity, both in design and implementation, let's say that they are fairly arguable. So you can have a very easy and immediate design and implementation, or if it scales, sometimes it may trigger like some extra layer of design that you have to deal with. Here we are, you can see one of our latest design. We have used, for example, multi-agent system for a campaign in e-health, which is a smoking cessation campaign. And we leverage on the behavioral change using agents for the behavioral change of the user. This was, as you can see, every user is mapped with a personalized agent that has its own profile. It has a computational model, and it wraps above all what the user shares, what user represents, so it learns from the user. And then, as we can see on the back end, it's connected with, for example, a physician that was handling the campaign for smoking cessation, from the tracking to handling the craving moments. And all the agents that are broken down from the coordinator, mediator, the coach, the behavioral agent, can be somehow programmed or managed, handled by the physician, maybe adjusting a treatment, adjusting an approach that can work for one type of patient rather than another, and that these virtual agent can intercommunicate and learn from each other, for example, seamlessly. If one agent says, okay, I'm giving tips to my user to stop smoking, like a practical example, and the user is always replaying with not interested, boring, repetitive, whatever, so it doesn't have acceptance. Let's say we are not able yet to create new, brand new from scratch solutions, but what the agent are able to do here is to see similar profiles. So the backend agents will interact with each other, trying to cross-combinate which information are necessary to then propose new approaches to its own user that it maybe can inherit or derive from similar profiles. So it's quite complex, and as you can see, when there are personalization and user wrapping and so on, all these concepts, they play a really well role, and they are kind of easy to design, to manipulate. Speaking about this distributed and this connection with humans, of course, we have to come to the concept of trust, which bridges us to the security concerns. And having this preponderant social side, that is one of the plus of this approach, we can define that the trust is a belief that an agent has that the other party will do what he promised to, or that will reciprocate a behavior that has been given, without catching the opportunity of defecting to maximize his gain or his payoff. So this is, let's say, a good approximation for defining what trust means. And this, coupled with the concept of reputation, is what we try to enforce and to model in our system that actually bridges the two worlds. Really briefly, speaking about the permission blockchain, that are the ones that we use, in particular Hyperledger, are the one that we use in our prototype. Blockchain are just a ledger, a distributed ledger, that distributes not only the registry, not only the data, but also the logic that goes with it, that computes it. And the fundamental components that we use to integrate this technology with our dynamics from the multi-agent system are, of course, the ledger, the word state DB, and the smart contracts, the logic. So how it works is that we send a transaction, the peers invokes the word state for having this transaction, and that is used by the peers. And then the transactions are grouped, and according to the triggering condition that can be time or number of transactions, a new block gets added, and then the word state, if necessary, gets updated. So according to this dynamic, we have merged the underlying mechanism of the two platforms. The platform that we choose, we will see later on, for the multi-agent system is Jade, which is Java-based, and for the blockchain is Fabric Hyperledger. So we didn't only bridge the two technologies, putting them in contact, but we wanted to merge them. So while we could not put, of course, for security reasons, our hands under the Hyperledger hoods, we did it with a multi-agent system. And in particular, here is the schema of what we did. So let's see what Jade Agent Platform provides. Is the BCA, which is the regular agent that participates in and interacts within a community. Then we have the AMS, Agent Management System, which is the guy that handles the community, that handles the platform and the underlying mechanism. And then there is the DF, which is the Directory Facilitator, which is the agent that keeps track of which agent knows how to do which service, and often also at which condition, with which parameters. Now, many platforms like Jade, they provide by default only one agent, that is the DF. And this can be seen also as a point of failure, single point of failure, or as an easy point to attack and to get out information from. So this is the first thing that we removed from the internal dynamics and that we translated into a distributed ledger. So all the binding between service provided, who provides them, and the track of these services that can vary over the time has been stored in the ledger, so that we can also spot in, for example, cases like, okay, now in case of pandemia, the price of the alcohol for the hands is quite evident that it's spiked up. And but there are some other services that may vary over the time and may create subpools that are not so blatantly visible to the users. And then you can, with proper routines, exploring the history of the ledger, try to spot intentional or unintentional misbehaviors. Anyway, let's see which dynamics get into here. Let's assume the first agent wants to join this platform for doing whatever action, for participating in the dynamic on a given system. Later on, I will also provide you an example of a practical implementation that we did. And he will ask to join the administrator, let's say. And the guy on the border, if some validation are matched, some condition are matched, he will ask the membership service to give any certificates. And if the membership service will agree with given condition, then it will receive the certificate that will be registered in the name of that agent, so that that agent can start querying the ledger and can start interacting in the platform. Not only the DF is realized on the ledger, but also a copy of all the behaviors of the agents will be stored in that, and all the interaction that happens between one another will be stored in this ledger, so that we can track whatever happened in any time. Of course, now I give just a little notion about that, plus the design of the reputation. So we don't only want to check who interact with who, but also we want to monitor the reputation, let's say, to enforce the trust and to keep the platform clean. Let's say we set a threshold that if you go below the threshold, you get kicked out from the platform. And of course, there are many discussion and reasoning about, okay, how do you compute it? And we provided 1 hour interpretation, which we can see soon. But giving a closer eye of how we realized the underlying architecture, we just saw that there are two main typology of agent. The one that controls or that spoons the community, the platform, and the agent that participates to it. So we have several components that, of course, require a different implementation. One's principally dealing only with the certification management, so it's limited to that. And all the regular user, regular agents that participate to the community have all the rest of functionality of behaviors that regards joining, interaction, services, and so on. And of course, on the other side, on the Hyperledger side, we had to realize the same functionalities, mapping them on the chain code. So we have a one-to-one mapping here from Hyperledger to Jade platform. And as you may see, the functionalities are the same. One little problem that we encountered with using Level DB is that is not a relational DB. So playing with the composite keys, we realized a relational-like database that was enabling us to represent connection, to query, and to store efficiently, let's say, the value of the reputation. The practical case study that I'm going to present is the outcome of a collaboration with a startup that is named In Mind, and I believe it's located in Zurich or in the German area. And basically, they have a platform for evaluating, assessing the capabilities of the startups as a potentiality. But of course, they wanted to model the dynamics according to our view, bridging the agents and the blockchains. So what we did is modeling the main player of this platform, which are the startups, the experts that evaluate the startups, and the investors that, according to the evaluation given by the expert, may decide to invest. Now, one may say, okay, which are the tangible risks here? Why do we need blockchain? Why do we need agents? One big first answer is like the modelization in terms of social interaction. It comes pretty along with it. So it has been pretty straightforward to model the dynamics of the system. And the second is that there might be a very high risk of generating mini pool or of having, let's say, coalitions or having selfish behaviors. Rough example may be that the expert may be also an investor that may rate badly a startup, trying to lower its reputation or trying to lower the cost and then investing in it at a cheaper price or buying it at a cheaper price. So exploiting some dynamics of the platforms. And of course, in a regular platform, you may see some behavior, but you may not see all of that, or you may not have all the mechanisms to investigate these behaviors. And since we had already this idea of tracking all the behaviors among all the entities participating in the platform, we, as you can see, developed this platform with several behaviors, from registering to requiring an assessment to investing to negotiating something. But of course, I'm going to just give a quick example about only a few of them. So we are not going to go through the entire scenario. And we're going to proceed step by step to see how the basic interaction, let's say, not the entire framework, work. Let's assume we have two startups that want to be evaluated initially, to be exposed to investors. We have here the bulb that is the brain of the agent, and of course the ledger, the chain. Let's say the startup one registers to the chain, and we impose that after the registration, before interacting with anybody else, they need to provide a self-assessment as required by the In Mind firm. After this, let's assume startup one does it. We have startup two and expert that they register themselves as well. For the expert is not needed the self-assessment. For the startups, yes. So different behavior personalized for the type of profile. Let's say in the scenario A that startup one starts to demanding for an evaluation, in which case here we say the expert one answers positively, he does his evaluation. He writes it down according to what he has to write. Partially will be on the StateDB, partially will go on the ledger, according to the specific need, of course. And all the interactions are then tracked down. Of course, Startup One cannot try, although he may see that the agent, the expert to register to the platform, but he didn't complete this process, so he's not reachable. Let's say Startup 2 that only registered, but is lacking one important step, that is the self-assessment, is not allowed, according to the smart contract, to operate into the platform. So until everything is matched and is checked, his correctness is checked by the smart contract, no interaction is allowed. Then going ahead, let's assume that later on Expert 2 completes his profile, and now he will be reachable. He can be contacted by Startup 1 that as well will negotiate his evaluation, and they can go further in the interaction. Now it comes back again, the question of reputation, which we applied to, okay, how well am I performing? How good am I as an expert? And we, in this simple case, we said, okay, we have one valuation given by, let's say, to make the simple case, by who provides the service and by who receives the service. Let's say agent A says, okay, I've done the service and I give myself 5. The receiver agent says, no, I evaluate your service 2. Now, unless a small epsilon as a divergence between the two evaluations from the executor and the demander, if the divergence is pretty relative, it's pretty big, then we, of course, we store the interaction, and then we trigger a behavior that says, hey, one of the two may reconsider their valuation of the service. And so adjusting the scores, adjusting the marks, then we can go ahead and we can align the two view. Or if an evaluation is not, in an agreement is not reached, we trigger a disagreement resolution policy. In the specific case, the policies have been of two types. One was to trigger, to ask for a third opinion. And once in the case that was something that was automatically, let's say, verifiable, we were running some sanity check on the objective to see, okay, yeah, this is objectively done well, this is not. Of course, this very depends on the scenario that we are studying. So all these mechanisms, of course, they are going to change the reputation, which is computed in how well I perform. If all the time, for example, an expert gives a mark that is, let's say, rightful and that is not disputed, then his reputation as a good assessor either improves or stays steady. Otherwise, if I am trying to, let's say, push somebody down and the community says, no, this is a good startup, there's no way that you are going to give a bad mark, or things like this that now I'm trying to simplify, but actually on the back end, we had several scenarios to analyze. So if some behaviors are not too clear, then they are still registered. And we had developed also some smart contracts that periodically they screen the history of the network, trying to spot if there are some trends, some repetitive actions, or some, for example, I give a bad mark and this my honest mistake, or I tend to give bad marks because I want to push down a certain type of startups rather than promoting some others for whatever reason. So here we can, let's say, foster some pattern learning, machine learning above the behaviors of the players within a ledger. Here is an early prototype that one of our students realized, and is actually just doing what we did, what I just discussed. The interface, of course, is not this anymore. This was the early implementation for his thesis. And as you can see, he's negotiating the execution of some services, simulating the ITO course, and then he's giving marks. And as you can see on the bottom left corner, there are 3 peers that are executing the transaction and are recording any behavior that occurs on the network. Now here we had 2 approaches. One was to couple every agent with one peer, so being the maintainer of the peer, or decoupling the logic of the agent with the maintainer of the peer. Because sometimes you may need for some I don't know, GDPR condition or some extra regulations that the data are in a specific place, still distributed, but not possessed by everybody, by every agent participating in the network. And as you can see, the reputation changes. Let's say there was a demonstration to show that the network behind works, so that the agent actually communicates with blockchain and that we can retrieve the data, which is, this was one log where you can see that is slightly messed, the information, but everything is precise and is reachable over the time. So we can reconstruct the entire dynamics of the system by analyzing with like some smart contract that analyzes the history. Now, what we can see here is that we had several possibilities of applying the blockchain and multi-agent system, and we have to admit that in many situations, blockchain is not always the answer. By this, I mean that sometimes it's not simplifying the situation, but is also overcomplicating it. So it really needs to be critically assessed if one solution, one industry, one corporation needs that kind of technologies according to its requirements and needs. So this is a first point of discussion. And as things are today, let's say we had several advantages. We could spot several, let's say, intentional or at least assess, try to guess some intentional, unintentional biases or misbehaviors. Back in time, in the ages, one big way of expressing, let's say, trust was using a trusted third party that we removed, because a trusted third party is somehow another point of failure that can be compromised. Here, the trusted third party is the blockchain, the technology itself. On the other hand, though, there is a non-negligible overhead in the whole overall dynamics, because we connected two big existing technologies that initially were not meant to cooperate, although they work pretty well, and the integration has been quite complex. And when let's say these dynamics are so complex, there may be the risk of not seeing further risks, especially security risks, in the integration of these two worlds. So the question here is, we liked it, it worked, but might be the case that we need to develop a further technology, a further platform that natively reconciles these concepts of agents, of distributed system, dynamic distributed system, and concept implemented by the blockchains. In the future works and ongoing work that we are conducting and willing to open now, we can mention a few technological open challenges and some challenges that tend to be more ethical than technological. Just to mention a few that we are more interested in is, for example, how to have, because in more multiple membership service of multiple order, for example, which is the element that keeps synchronized the peers. Because in the implementation, in the version, I think it was 1.1 that we had of Hyperledger, there was only one at the moment. Of course, when you integrate, MAS are really extremely scalable. Blockchain with some conditions. And when merging them, due to this complex integration, the scalability is slightly hampered. So you really need to take care of how you deploy and you design things. So even here, fostering the scalability in merging these two worlds is quite of a challenge right now. And of course, I didn't mention yet, but let's say one concept of multi-agent system is one community of agents, but we may have more communities that they may speak and share the same language or having different standardizations. And even this, reconciling these different standards when also having different possibly typology of blockchains behind public, private, or whatever, it may be another big challenge. So it's another layer on top. And in turns, we have the challenge of having this mechanism reliable. So are there good practice, like how to have reliable mechanisms in bridging these two technologies? And okay, can we develop smart contracts that match the behavior of the user, of the agent, sorry. Although we may have some behaviors that are either data dependent or they may evolve over the time. And how do we amend the smart contracts? Who we need to call? Can it be done automatically? Is that reliable? So there are so many questions about that we are trying to, let's say, answer or give our interpretation to. And okay, then there are technical, for example, immutability of the smart contracts. We had a brief experience with an industry that said, yeah, I would like to implement the blockchain, but our processes are quite dynamic. So we may need sometimes to do hot fixing in RAM. But how can we do it if there are some smart contracts, if the blockchain is already running? Like, the hot fixing is not really easy, at least according to the analysis and the discussion that we had with this firm. And then always going towards the question, who is autonomous, who is developing the smart contracts? Can it be the case that some agents, to foster autonomy, can develop the smart contract himself, can have, okay, bounded behaviors, can have checked code, but still, can it be done? Can it be delegated? Will it be accountable? And this last question brings us, of course, to the ethical open challenges that belong to this project, to this idea of bridging these two technologies. The first one that I had to face, and is named the erosion of the social cultural blockchain ecosystem, is that, okay, the idea is to have an egalitarian technologies. But when you, matter of fact, go to check it, is for industries expensive to get, expensive to maintain, and matter of fact is not really egalitarian anymore. So there are several studies, especially the Gini index, that they declare that there is a big imbalance within this ecosystem, and that can be badly exploited. So that was the overall risk. Then another point is that the complexity of the smart contract may be explode, because of course blockchains are being employed in more and more scenarios, so they have to satisfy some needs maybe they were not meant to, and maybe there can be some behavior that can be that complex that at the moment of development are hard to be foreseen. And then even here, can everything be checked? Can everything, like, how can it be handled during its evolution? Even here, we bridge two technologies, and those are workarounds, let's say. Every workaround may have some implication and some limitations. Even here, who is accountable? If we need to move some data treated in a certain way or differently from each platform, like, who is accountable for, which is the legal basis we should account for. And even here, who develops the smart contracts or who implements the blockchain often is not the owner of the business. So if anything needs to be changed, who is liable for that? Who has to be called? And there are many dynamics that at the moment of, like, let's say the study that is being conducted in that paper were still not really clear, and that claimed for let's say a clarification for a solution. Here, this is the first point of this list here, liability in AI delegation, is quite relevant, and we are quite interested also in analyzing this. Let's say in the coupling between human user and virtual agent, sometimes we delegate basic things. I don't want to say just talking with Amazon Alexa, booking a field, turning on a light, whatever action that we may directly or implicitly indirectly ask to a virtual assistant may have consequences. And what if, for example, we run a bot on stock actions, and for whatever reason, this bot loses money or does something that was not supposed to because one of its behavior evolved in a given way that the human user were disagreeing. So where the liability of the human user and of the AI system and of the blockchain system starts, begins and ends. So this is also like a quite scale of gray areas. And of course, all but God, still the right to be forgotten. Concerning this topic, we recently, only with a proof of concept on embedding agents in there, we realized a system that enables the dynamic management of the consent, of the patient consent for clinical trials. And this is also a very interesting, let's say, branch of research that we are dealing with, of course, still with several open questions. And then we had a discussion with a few industries as well, that they were claiming like, okay, we want to go into this world, but there's no actually a clear legal base for bridging AI and blockchain. So how should we actually move? And this is, I think, is still a big open question on its own. So these last two slides are the topic we are working or willing to work on, if anybody is interested. So for the moment, I hope I gave enough inputs to the audience, and that it triggered any questions, hopefully easy ones.